All right, welcome in everyone. Ready for another deep dive? Today we're going to be tackling something called computational thinking.
Computational thinking.
Now I know it might sound kind of intimidating, all techie and stuff, but trust me, stick with us on this one.
Yeah. It's really not as scary as it sounds.
Right, it's not just for, the coding geniuses out there. It's actually a way of thinking about problems.
A way of solving problems.
Exactly, a way of solving problems that, get this, both computers and humans can understand.
That's the cool part.
I know, right? So we've got some awesome sources we're going to be diving into today. We've got like actual definitions to help us wrap our heads around it.
We got to start with the basics.
Yeah. But then it gets even cooler. We've got, wait for it, a visual breakdown of dance moves.
Dance moves. Seriously.
Seriously. It's going to all make sense, I promise. Intrigued.
All right, you got me hooked. Let's do it.
Okay, so let's jump right in with those definitions. I'm curious, like, where do we even begin with something like this?
Well, our first source, it really kind of dives headfirst into this whole concept of a problem.
A problem. Okay, so that seems pretty straightforward. But I'm guessing there's a bit more to it than just, everyday problems.
Yeah, you're right. When we talk about problems in computational thinking, we're not just talking about like, spilling coffee on your shirt or missing the bus.
Okay, good to know. So what are we actually talking about then?
It's more about any situation, really, where you have a specific goal you're trying to reach, like a desired outcome.
A desired outcome. Okay, so like, I don't know, like let's say you want to plan a vacation.
Exactly. Let's go with that.
Yeah.
So you want to plan this awesome, relaxing vacation, but you also don't want to totally empty your bank account, right?
Right. Who does?
Exactly. So that's your problem you got to solve. Planning that perfect getaway without going broke.
Okay, I see.
Yeah.
So it's like taking this big goal and turning it into a problem that needs solving. And I'm guessing computational thinking gives us like a framework to do that.
You got it. And the first step in that framework, it's called decomposition.
Decomposition. All right, break it down for me.
Basically, you take that big, maybe kind of overwhelming problem, in this case, planning your whole vacation, and you break it down into smaller, more manageable steps.
Smaller steps. Okay, so instead of just plan my dream vacation, it's like, what?
It's more like figure out flights than find a place to stay.
Research activities.
Exactly. Breaking it down into bite-sized pieces, makes it less daunting.
It definitely does. But I'm guessing there's got to be more to it than just making a to-do list, right?
Oh, absolutely. As you start breaking these things down, something interesting happens. You start to notice patterns.
Patterns.
Yeah, like maybe you realize that hotel prices always seem to drop if you book midweek.
Interesting.
Or maybe you find that flying on certain days of the week is way cheaper.
Okay, that's actually pretty useful. So this is where pattern recognition comes in.
Boom, you got it. It's not just about dividing the problem, it's about recognizing those recurring themes that can help us be more efficient.
More efficient and hopefully save some money too. So where do algorithms fit into all of this?
Ah, good question. An algorithm, it's basically just a set of steps that you follow in a specific order to solve a problem. Think of it like a recipe you follow in the kitchen.
Okay, I can see that.
So for our vacation planning, our algorithm might be first, search for flights on Tuesdays for the best deals.
Got it.
Then compare hotel prices on different websites to find the best value. And finally, look for activities that fit our budget and interests.
Wow, so our whole vacation plan becomes an algorithm.
Exactly. It's just a step-by-step guide to reach our desired outcome.
That's so cool. Okay, but here's the thought. With all this breaking things down and analyzing and whatnot, isn't there a risk of, like, overcomplicating things?
Overcomplicated.
Yeah, like getting bogged down in all
Yeah.
the tiny details.
Right. Ah, I see what you mean. And that is a valid concern. But that's where abstraction comes in to save the day.
Abstraction, that sounds kind of, well, abstract.
It's really not that complicated. It basically means focusing on the most important elements and filtering out all the unnecessary noise.
Filtering out the noise. Okay, so, like, do I really need to know the thread count of the sheets at every hotel I'm considering?
Probably not, unless you're like a sheet connoisseur.
Not so much.
Right, so focusing on things like location, price, reviews, that's a form of abstraction. You're zeroing in on what really matters.
Okay, I'm starting to see how all these pieces fit together, but there's still a few things I'm a little fuzzy on.
Hit me.
Okay, so we've got code, computers, and code blocks. Are those, like, only relevant if you're actually writing computer programs?
Ah, that's a great question. You can think of code as the language we use to communicate with computers.
A language.
Yeah, it's those step-by-step instructions we give them.
Like instructions for the computer.
Exactly. And code blocks, well, they're kind of like prepackaged sets of instructions for specific tasks. Makes things a little easier for the programmer.
I see.
And of course, a computer, that's the machine that actually understands and executes all those instructions we give it through code.
Okay, so those are like the tools and the language that programmers use. But what's really cool is how these same principles, this whole computational thinking thing, it can be applied to all sorts of stuff beyond just coding, right?
Absolutely. It's a way of thinking, a problem-solving mindset. You can use it everywhere.
Which brings us to that dance move example.
Ah, yes. This is where it all comes together.
So we've got this visual example, right, that shows how computational thinking works in action. What are we looking at here?
Okay, so we see a sequence of dance moves all broken down, like crisscross, jump, crisscross, something like that.
Crisscross, jump, crisscross.
Yeah.
Got it. And there are markings like ×2, ×1. What are those all about?
Ah, those are showing us repetition, like how many times you do a certain move in a row.
Okay, repetition. Got it. So how does this all connect back to those computational thinking concepts we were talking about?
All right, well, think about it. The dance itself, learning this whole sequence of moves, that's our problem we need to solve.
Okay, I see that.
And then breaking that dance down into individual steps like crisscross, jump, whatever, that's decomposition.
Decomposing the band.
Exactly. And then noticing that crisscross pattern, seeing that it repeats, that's pattern recognition.
Pattern recognition in action.
Right. And then the whole sequence, from start to finish, all those moves in order, that becomes our algorithm for the dance.
Wow, that's a really clever way to think about it. But let's be real, most of us aren't going to become professional dancers anytime soon.
True, true.
So besides planning vacations and learning fancy dance moves, where else can we actually apply this computational thinking mindset?
Oh, man, it's more common than you think. Imagine you're, I don't know, cooking a complicated recipe.
Okay, cooking.
You've got all these different steps, ingredients to add in the right order, maybe some techniques you got to master.
Right, it can be a lot.
But you break it down into stages, you recognize patterns in the instructions, you follow the steps carefully. Boom. Computational thinking in the kitchen.
Wow, I never thought about it like that.
Or how about, let's say you're organizing a huge marketing campaign.
Okay, marketing campaign. That sounds pretty complex.
It can be, but you can use computational thinking to tackle it. You identify your target audience, you break down your message into key points, you create a content calendar to stay organized.
So computational thinking can help us be more strategic.
You got it. It's about approaching any complex task with a structured, analytical mindset.
Structured, analytical. Okay, I like it. So it's really all about breaking things down, looking for those hidden patterns, and then creating a clear path to the solution.
Exactly. And here's the really cool part. There's often more than one way to solve a problem. More than one right answer.
More than one way. Okay,
yeah.
so how does that work with computational thinking?
Well, think back to that dance sequence we were looking at. You could decompose it in different ways, maybe focusing on the footwork instead of the arm movements.
Interesting.
Or you could represent those dance moves with symbols instead of words. There's flexibility in how you approach it.
Okay, so it's not just about finding the O solution. It's about exploring different paths to get there.
Exactly. That's part of what makes computational thinking so powerful. It's a flexible, adaptable way of thinking.
It's pretty amazing when you think about it. So even though we started off with what seemed like, some pretty technical jargon, it turns out computational thinking is a surprisingly useful tool for just about anyone.
Absolutely. It's about training your brain to think in a more structured, logical way. And who wouldn't benefit from that?
Seriously. Well, thanks for joining us on this deep dive. And next time you're faced with a tricky problem, big or small, remember, think like a computer.
But dance like nobody's watching.
Ah, I love it. All right, that's all for today, folks. See you next time.